All right, next up, let's look at evaluating using trig identities. Identities are basically formulas that we use with your trig ratios like sine, cosine, and tangent, mainly because now you'll see that you're not going to be dealing with just sine of an angle or cosine of an angle or tangent of an angle anymore. Now you're going to be dealing with tangent of, let's say, 2 times the angle or tangent of the angle divided in half. So when you kind of manipulate the angle, you're going to need these formulas to help you figure out the new values. All right, so the one on the left here, probably the most important one that you'll use in this section. So make sure you're very familiar with these sets of formulas right here, or identities actually. So like for example, over here you got sine squared plus cosine squared equals 1. This is like your main formula. And then what I've done on the side is that I've rewritten it in the situation where let's say you have sine squared and you want to replace it with this, or you have cosine squared and you want to replace it with that. Okay, so oftentimes in these problems you'll see that you don't always use it like this way. Sometimes you need to use variations of your identities, and that's what these guys over here are for. Okay, so again, just make sure you're very familiar with this block of formulas over here. All right. Again, there are many identities. So you've got like co-function identities, you've got even odd identities. These ones don't pop up as much, but I put them on here just in case they do show up in your problem. So again, be very familiar with this one over here and be on the lookout when you can apply these guys in the right situation. Okay. All right, so before we actually get into working out the problems, I just want to take a quick moment to discuss with you why it is that you need these identities. Okay, so over here, I have an example of the 3 major identities that we'll be working with. So the first one over here is the sum formula, a plus b. So what this means is you want to evaluate the sine of 2 separate angles added together. Over here, what you want to do is you want to evaluate the sine of twice the angle, or in this case, sine of the angle divided by 2. Now, I'm using sine for my examples here, but really what I'm about to say applies for any of the trig ratios. You know, it's the same for cosine, tangent, whatever. Okay, and what's going on is, for example, over here you see sine of a plus b. If I didn't tell you what to do, your intuition would probably tell you this looks like a distributive property. Let me just throw the sign in here, make this sine A plus sine B, evaluate those things, and then get your answer. Okay, and you would get an answer, but that answer would be completely wrong. Same thing over here. If I didn't tell you what to do, if I didn't tell you how to evaluate sine of twice the angle, you might naturally think this looks like it would be the same as if I were just to take sine of the angle and then double it. Or in this case, if I were to take sine of the angle and then take that answer and divide it by 2. Okay, so these are all intuitive things you would think about. And if they were correct, then that'd be great. And you wouldn't need a formula, because you don't need a formula to tell you for this guy to write it like this, or for this one to write it like that. It's natural, you know, it comes to you. But all of these over here don't work. Okay, they may seem like they should work, but they actually don't. And because they don't, that's why you have to use a formula. So long story short, when you see these guys over here, don't do the stuff on the right. Okay, always remind yourself you have to use a formula to actually figure out, you know, what the answer is. There might be a small percentage where you don't actually have to use the expanded formula to help you out, but even in those situations, you still wouldn't use what you see here. Okay, so the next question, I guess, would probably be, well, why not? Okay, like, are you just trying to make life, you know, harder on me? Why can't I use those? And again, the reason is I'm not trying to forbid you from doing something, you know, just because I want you to practice a formula, but rather, you know, if you do these, you actually get the wrong answer. So it's not like, you know, you have a choice here. Okay, so this one is probably the easiest to show you why it doesn't work. Okay, so for example, let's take sine of 90 degrees. Okay, you know sine of 90 is equal to 1. All right, you also know that sine of 90 divided by 2 is the same as sine of 45, which is going to be the same as rad 2 over 2, which in decimal form is going to be the same as 0.707. Okay. All right, so let's kind of apply that to what this is saying over here, okay? If this was true, then what you're saying is if I take sine of 90 over 2, that's going to be the same as sine of 90, whatever this is, divided by 2, okay? Sine of 90 over 2, we just said, is the same as sine of 45. Sine of 45, we just said, was this, which is equal to that, so it's 0.707, okay? However, when you look at this guy over here, sine of 90 is 1, right? 1 divided by 2 is 0.5, and obviously these guys over here do not match up. Okay, so mathematically, that's why this guy doesn't work. I have a circle over here because I want to also show you visually why it doesn't work. So in this situation, let's look at this guy and see if I can kind of show you visually why this doesn't equal that. Okay, so let's start with, for example, here I have alpha, but it doesn't matter. I can always use a theta in this case. So let me just change all these to theta. Okay. So in this diagram, as you can see, my original angle is this guy down here. Okay. If I wanted to figure out what sine of this angle is, remember on a circle, assuming it's a unit circle, that would be this length over here, right? This would represent the sine value. So let me just kind of highlight that in green. Okay, so this is your original sine theta over here. Now, I don't know how much this is, but let's say I wanted to double it, okay? I think reasonably speaking, if I were to double the angle, it would probably be about this much, right? Like this extra portion that I added here looks to be, you know, about the same length as this guy. So now I would say this angle is double of the original one, okay? Now, if you look at this guy over here, the triangle that goes with this guy, that's this one right here, right? So let me trace it for you real fast. Hopefully you'll just be able to follow along. But long story short, for this new angle over here, which is now 2 theta, if I were to do sine of 2 theta, basically what that means is I would want to look at this triangle that I'm kind of tracing with the red dot and figure out, well, what is the sine of this triangle? And once again, the sine of this triangle would be the vertical part. So that would be, I guess we could stay with green. That would be this guy right here. Okay. Now, when you look at it, obviously this guy is going to be longer than this guy, but would you say that this guy is twice the height of this guy? And obviously it's not. If it were to be twice, I believe twice would be like this, like it'd have to be like up here. Okay, so visually, I don't know if this helped or not, but visually, that's why this is not true. Okay, you have to understand that when you double an angle, so in other words, when you double this part over here, it doesn't mean that this part is also going to double as well. Okay, it's going to get bigger likely, but it's not going to get, you know, twice as big. How much bigger is it going to get? Like how much is this new length going to be? That's where you're going to have to use a formula to help you figure out exactly how much. Okay, so hopefully this gives you a better idea of why it is we're going to need to use the formulas. All right, so let's take a look at how your sum and difference identities would work. Okay, so over here, you've got all your formulas, and over here we've got some practice problems for you to use these formulas with. Okay, so let's start with this guy over here. This is a typical problem in which you would use your identity for. So it asks you find the exact value of sine of 75 degrees. Okay, so the first thing you actually want to do is ask yourself, well, where is 75 degrees? Is it one of those nice points on the circle? If it is, then, you know, you just use your circle and figure out, you know, what the value is. Unfortunately, 75 is not one of those. Okay, 90 degrees is, 60 degrees also is, but not 75. Okay, so you know that it's definitely less than sine of 90, which is basically 1, but it's also greater than sine of 60, which is rad 3 over 2. So you know basically that the value of this has to be something in between rad 3 over 2 and 1. And sure enough, if you were to type in your calculator, it would show you that the decimal value is definitely somewhere in between there. Okay, but again, here I want an exact value. Since I want an exact value, to do that, you're going to have to use one of these formulas over here. Okay, so this is how it works if you want to do it exactly. All right. Obviously, in order to use this formula, I need two angles over here, A and B. So what you're really asking yourself over here is, what two angles should I split up 75 into? Should I split it up into like maybe I don't know, 60 plus 15, or should I split it up into, let's say, 40 plus 35? And the idea here is you can actually use whatever you want. You could have even used, if you wanted to, 70 plus 5. Again, the possibilities are endless. But here's the thing. If, let's say, since we're using addition, you know we're going to have to use this guy over here. If you look at what the formula actually is for this part, it says sine of A plus B is equal to sine of A cosine B, sine of B cosine A. So if you look at these parts, basically what this tells you then is eventually you're going to have to take these angles and fill them in here, and then you're going to have to evaluate these guys. And if you can't come up with the exact values when you do that, then pretty much that renders your formula useless. Okay, so what I mean by that is, for example, if let's say we chose this combination to represent 75 and we tried to plug it in here, if I plug the 60 into here, and I try to do sine of 60 and cosine 60, that's no problem. Okay, I can do that because that's a nice value on the circle. But if I were to put the 15 into here, and I try to evaluate it, well, I'm stuck again because, cosine 15, isn't something nice on the circle. So once again, I got to use my calculator, and at that point, I'm not going to be exact anymore. Okay, so long story short, what I'm trying to tell you is when you choose these two angles over here, you can choose whatever you want, but the requirement in order to use the formula then is you have to make sure that you actually choose two values that are nice values on the circle. So in this case then, if you look at the problem, this is bad, these are both bad, and originally I wrote this to be correct, but if you think about it, you don't have a 40 and a 35 on there. I think what I meant to say here was 45 and 30. Okay, 45 and 30 also give you 75, but this is better because these are nice values along the circle. Okay, so for 75 then, what we want to do is we want to say sine of 75 is actually equal to sine of 45 plus 30, okay? And if you swap this around, you're like, oh, I put a 30 here and a 45 there. Am I going to get the wrong answer? You will not, okay? You'll plug it in differently than me into this formula, but you'll still get it correctly, okay? If you do everything correctly. So if I take this now and I expand it out over here, I'm going to get sine of 45 cosine of 30 plus sine of 30 cosine of 45. Okay, so that's me taking the 45 and the 30, plugging it into here correctly, and then now all you have to do is just evaluate these four correctly. Okay, so sine of 45 is rad 2 over 2. Cosine of 30 is, I believe, rad 3 over 2. Sine of 30 is going to be 1/2, and then cosine of 45 is going to be rad 2 over 2. Okay, so when we take these guys and try to simplify it as best we can, rad 2 and rad 3 is going to give me rad 6. This is just going to be rad 2 on the top, and then it's going to be all over 2. Okay, so this is your exact answer for this guy over here. Okay. Again, in this case, I use the addition. If you wanted to, you could also use subtraction. You just have to, again, come up with two angles that would have subtracted nicely to get you 75, and individually, they have to be nice values along the circle, okay? All right, let's move on and try to do cosine of 11 pi over 12. Okay, now 11 pi over 12, it might be harder for you because, again, I think radians, it's kind of hard to visualize. A lot of times when you see it in degrees, it's easier. So for this one, if you want to just convert this to degrees and then have an easier time figuring it out from there, that's totally fine. In this case, you're allowed to switch from radians to degrees, because at the end of the day, your answer is going to look like this anyway. Okay, so if we do 11 pi over 12 and I multiply by 180 over pi, I am going to get, this is the same as finding cosine of 165. Okay, so if you have an easier time trying to figure out two angles that give you 165 as opposed to 11 pi over 12, then go ahead and use this instead. Okay. Okay, so once again, you want to come up with two angles that are going to either add or subtract to give you 165. I think adding probably would be the most obvious option here, and you're totally, fine to do that. But since I showed you an adding example over here, I'm going to use a subtraction example to break this one up. So in this case, I'm going to go with the difference identity. So that means I want to use this one down here. Cosine of 165, I think I can break that up into cosine of 210 minus 45. Both of these are nice values on the circle, so that works out. So when I use this formula over here, it will be cosine of 210 cosine of 45 plus sine of 210 sine of 45. Okay, so once again, I evaluate these guys individually, and then I just, kind of squish them together. Okay, so cosine of 210, if you look on your circle, I believe that is going to be negative rad 3 over 2. Cosine of 45 is just going to be regular rad 2 over 2. Sine of 210, I believe, is going to be negative 1/2. And sine of 45 is going to be just regular 2 over 2. So if you take this and combine it together, I think you'll get negative rad 6 minus rad 2 over 2. You'll notice that this is very, similar to this, and don't be surprised. A lot of times that'll happen. Like you might get the same numbers up here. It'll just be off by maybe like one negative or two negatives, but the numbers are the same. So if that does happen, like I said, don't let that like throw you off. It doesn't mean you did it wrong. It's very possible. Okay, so again, this was an example using addition. This was an example using subtraction. And then for this example over here, notice you already have the numbers in here, so you're more than welcome to actually apply the formula. So this will be sine of, let's see, if I look up here, it'll be sine of 120 cosine of 30 minus, so sine of 120 cosine 30 minus sine of 30 cosine of 120. So again, you're more than welcome to do the formula over here, but the reason why I gave you this example is just to let you know, sometimes, just simplifying it and looking at what you're dealing with, you can do it a lot easier. 120 minus 30 is the same as just 90. Okay, so really this is asking you what is sine of 90, and you don't need a special formula for that. Sine of 90, is just 1. Okay, so when applicable, I would just kind of look at this real fast and say, hey, can I actually do this without using the formula? Obviously, most of the time you're probably going to have to use the formula, but there will be some times in which, just looking at it the other way will be a lot faster. Now, if you actually did it this way, you'll see that when you simplify this up, you will also get 1. It's not like if you did it this way, you would get the wrong answer. Okay, if you carried out the calculation here, you would also end up with 1 as well. Okay. Okay, so next up, instead of them giving you an angle and you having to figure out, what two smaller angles to break it up into, they're actually going to give you the angles A and B, but they won't give it to you directly. they'll give you some information about it, and then you're going to have to draw a reference triangle to kind of help you fill out the rest. Okay, so for example, in here it says find the exact value of sine of a plus b. So that means if I'm going to do this, eventually I'm going to do this part over here. Okay, so let's start by writing out the formula. Sine A cosine B plus sine B cosine A. Okay, so what this is obviously telling you then is you need to know these four quantities in order to be able to solve this expression over here. So they tell you that for A, the cosine of A is -2 over rad 5, which is helpful because I'm going to need it for this spot over here. Okay, so I already know over here, I'm going to fill in this with -2 over rad 5. Okay. Likewise, it tells me that sine B is going to be -1 over 5, which is also helpful because I can fill it in over here. Okay, so I know that this is also going to be -1 over 5. However, it does not give me any direct information about these guys, but based on what it tells me over here, I should be able to figure out what this is if I remember how to draw the triangles. Okay, so it says where sine A is positive. So let's think about this. If cosine is -2 over rad 5, okay, and I want to draw a triangle where cosine is negative and sine is positive, where is that going to be? So hopefully you still remember how to do this and you realize that that is going to be in quadrant 2. Okay, so that means when I try to put the -2 over rad 5 over here, the -2 will be here, the rad 5 will be over here, which means if I work my way backwards using the Pythagorean, this squared minus this squared will equal to this squared. So that means if I take the square root, this guy over here has to equal to 1. Okay? So if this guy is 1, then obviously your angle is over here, and this is going to be what, angle A? Okay. If I already know what the cosine of this angle is, that's this over this, and now I need to figure out what the sine is. The sine for this picture is just going to be 1 over rad 5. So that means this part is now going to be 1 over rad 5. And let me just kind of move the drawing over so we have a little more space. Okay, so again, we had this A. I knew that it was -2 over rad 5, which means this has to be a 1. Okay, and again, the sine of this triangle is going to be opposite over hypotenuse, so that's going to be 1 over rad 5. Okay. Likewise, I'm going to do the same thing using this information over here. I'm going to draw a triangle for B. So for B, I want to figure out where sine is negative. So obviously that's got to be on the bottom somewhere, 3 or 4. Where tangent is also negative. So where tangent is also negative between 3 and 4 is going to be on 3. Okay, so if I draw that one, that's going to look like this. So that means this is B, this is sine, so -1 over 5 is actually going to be here. And if I work backwards with this one, let's see, 5 squared is 25, minus 1 is going to be 24. So I believe this one over here is going to be rad 24, okay? Which means this I will fill out with rad 24 over 5. Okay, so now all you got to do is just, combine like terms, well, multiply and then, kind of squish it together. So this guy over here looks like it's going to be rad 24 over 5 rad 5. Okay, so that's going to be 5 rad 5. And then this guy is also going to be 5 rad 5. But the top part, when you multiply it together, is going to be 2. So it's going to be this. All right. So I believe this is your final answer for this situation over here. Okay. All right, so in this situation, we're going to be dealing with tangent. You see the plus in the middle, so that means we're going to be using this identity over here. This case is actually very similar to the problem that we just did. The only difference here is that we're dealing with inverses, which means you have to remember about the boundary restrictions, but just like last time, you're going to have to draw a triangle to help you figure things out, okay? All right, so the first thing I would probably do is I would probably look at these parts and maybe start by drawing the triangle and then kind of evaluate it from there, okay? So when you look at this one over here, the cosine inverse of 1/2, what is the picture that goes with it, okay? So again, cosine inverse, it's going to be positive. That means it's got to be in the first quadrant, okay? If I want cosine to be 1/2 for this picture over here, that means I got to have 1 over here and 2 over there, okay? Which means if I work my way backwards, eventually this one over here is going to be rad 3, okay? Over here, for the sine inverse of negative 3 over 5, when I look at this guy over here, if sine's going to be negative, then that means it's got to be this picture over here, okay? The negative 3's got to be here, the 5's got to be here. When I work my way backwards, that means this length going across has to be a 4, okay? All right, so now what I would do is go ahead and let's do our formula, okay? So you know we're going to end up doing tangent of A plus tangent of B over 1 minus tangent A and tangent B. Okay, so this might, seem a little weird, but here's the idea here. Okay, so tangent of A is going to be the same as this right here is pretty much your A, and this right here is pretty much your B. Okay, so when I say tangent of A, what I mean is tangent of this. Well, what is this? This is represented by our triangle over here. So when I say tangent of A, really what I'm asking you to do is figure out what is the tangent of this picture over here, since this picture goes with cosine inverse of 1/2. Okay, so tangent of this picture is rad 3 over 1, which means this then is just going to be rad 3. Okay. Okay. Same idea over here. Tangent B. B in this case is going to be represented by sine inverse of negative 3 over 5, which, what is this really? This is this picture over here. Okay, so when I ask you what is tangent of B, what I'm really asking you is what is tangent of this picture? Well, tangent of this picture is going to be negative 3 over 4. So we'll just replace that here. And then we'll do the same thing down here. Okay, so when we clean this up then, that means we're going to get, let's see, negative 3 rad 3 over 4, 1 minus negative 3 rad 3 over 4. Okay, this one, I guess it'd be nice if you did simplify it, but to be honest with you, if you want to just leave it like this, that's fine. I'll have an idea where you got it from, as long as, I see these parts over here and I see the 2 triangles. Okay, so if you want to leave it like this, totally fine. You don't have to like simplify it for me. All right, but yeah, the idea again is take these guys over here, make sure you draw the correct triangles that go with them, and then use the triangles to help you figure out the trig parts of your formula over here. Okay? All right, last one for your sum and difference. For this one, notice you're trying to do secant. At first, that might bother you because, as you can see, you don't have a secant here anywhere. But remember, secant is related to one of your functions over here. Secant is the same as 1 over cosine. So really, if you ever see any of the reciprocal functions on here, what they want you to do is figure out what the original one is, and then when you get your value, just flip it, and then that'll become your reciprocal one. Okay, so really for this one, we're looking at cosine. So do everything in terms of cosine, and then when you're done, flip the answer, and then it'll actually be the secant. Okay, so if we look at cosine of alpha minus beta, that means we're going to be looking at this formula over here. Okay, so pretty much I'm going to want cosine of A, cosine of B minus sine A and sine B. Is that right? Let's see. Minus, oh no, minus, I need to have the plus in here, so it's going to be the plus. Okay. Okay, let's match up these A's and B's, with this and this so that when I refer back to it, I'll have an easier time. So let's see, the A's are alpha in this case, so I'll replace those with these guys, the fishies, and then the B's are going to be beta. Okay, so that's going to be this guy over here. All right. Okay, so just like last time, in order to solve this, you're going to want to figure out what these four values are. Okay, so obviously the alphas require me to look at the alpha picture. Okay, so when we look at the alpha picture, it tells you that this length over here, this hypotenuse length is 5. You can tell from the diagram then that if this is 4, 0 and this is 4, 3, that's got to be 4 and that's got to be 3 over here. Okay, so if I want to figure out cosine of this picture, then cosine is going to be adjacent over hypotenuse, so that's 4 over 5. So that means this guy's got to be 4 over 5. And then the sine of this picture has to be opposite over hypotenuse, so that'll be 3 over 5. So sine over here, it's got to be 3 over 5. Okay. If we move on to beta, okay, again, it's rad 13, it's 13 this way. And if it's -5 over here and -5, -12 over here, that means I went -5 this way and -12 that way. Okay, so based on this diagram then, that means, let's see, cosine is going to be -5 over 13. So cosine is going to be -5 over 13. And sine is going to be opposite over here, so that's -12 over 13. So -12 over 13. Since these are all like, nice numbers, I think you should, for once, be able to combine it into one nice fraction. Okay, so over here, this guy is going to be what, -20 over, I think, 65. This guy over here is going to be -36. So -20 minus 36 is -56, I think. So -56 over 65, I believe. Okay, so basically that's these two multiplied together plus these two multiplied together. That'll give you this. Since I'm actually looking for secant, secant then is just going to be when I flip this. So when I flip this, that'll be -65 over 56, and that'll be the answer for this part over here. Okay. All right, let's take a look at the double angle identities now. Okay, so we'll start with this problem over here. Find the exact value of cosine of 2 theta. Given cosine theta is equal to -rad24 over 7, where sine theta is positive. Okay, so obviously in this situation, they don't give you the angle directly. They give you some information about it. So your job is to kind of sketch the triangle again and use the sine and cosine on that triangle to kind of help you figure out this value over here. Okay, so based on the information that they gave us, we know that the triangle is in the second quadrant, because that's where cosine is negative and sine is positive. So if I fill this in, that means that's got to be -rad24. This has to be 7, and working backwards, that means this has to be a 5 over here. Okay. Looking at our formula for cosine of 2 theta, that's over here. you actually have three options. The other ones, you only have one option, but for cosine, you actually have three options. And if you look closely, you'll notice that one of your options is actually 2 cosine of the angle squared minus 1. So what that means is we actually could have figured this out knowing just the cosine, which we do know, which means technically for this problem, we didn't actually need to do this triangle over here if we use this option. So if we did use the middle one over here, all we would have to do is do 2, figure out what cosine of the angle is. That's negative rad 24 over 7, and then square it. So that means I would do 2 times negative rad 24 over 7 squared, and then minus 1. So if I just calculated this, then I could have gotten the answer directly like that. But since I found this, if I wanted to, I could also use this top one or this bottom one as well. So let me just show you real quickly what it would have looked like if you used this one or this one. So if we use the top one, it would have been cosine squared minus sine squared. The cosine we already know was negative rad 24 over 7 squared. And then minus sine squared in this case would have been 5 over 7. So 5 over 7 squared. So if you had done the calculations for this, it should end up giving you the same as this guy over here. And then a third option would have been this. So you could have done this as well. So this would have been 1 minus 2 times sine is 5 over 7 squared. Okay, so calculating any of these three would have gotten you the same answer. Okay, and you don't need to do all three. You just need to do one of them. Again, I'm just showing you all three since we have the information. Okay, next up, it says find the exact value of tangent of 2 theta given the triangle. So once again, they don't actually tell you what the angle is, or else you could just plug it in directly and figure it out. But you do have enough information when you use the triangle to plug it in here. Okay, so we want, let's see, 2 tangent a over 1 minus tangent a squared. Okay, I'm just going to write it like this, even though it's written like this, because this will make it easier for me to plug things in. And to be honest with you, it means the same thing when you see it like that. Okay. All right, so really, in order to simplify this, I just need to know what tangent is for our picture. Okay, so for our picture, they give you a 12 here, they give you a 13 here, but you don't know this side over here, and without this side, you can't figure out tangent. Okay, but you can figure this out, what this is by going backwards, because this is a right triangle. So 13 squared minus 12 squared, take the square root of that. I believe, once again, that'll give us a 5 over here, if I'm not mistaken. Okay, so that means the tangent then for this picture is going to be 5 over 12. So all I have to do is replace these guys with 5 over 12 and 5 over 12 in here. Simplify, do the math, get your answer. Okay, so that part I think you can finish off on your own. And then lastly, we've got this situation over here. It says find the exact value of sine 2 theta given cosine theta is equal to 2 over 3 in the fourth quadrant. So again, we go to our sine formula, that's this guy, that requires us to have sine and cosine. So in this case, you might as well draw the triangle because you're going to need it. Since we only have cosine, we need to figure out what sine is. So based on this picture, knowing it's in the fourth quadrant, that means it's got to look like this. That means you're going to have a 2 here. You're going to have a 3 over here. So working backwards, that means this guy over here, since this is a right triangle, is going to be, let's see, 9, 4, 5, so rad 5. Okay. And that means when we plug it into the formula over here, 2 sine A cosine A, the sine A part, the cosine A we had from the given information. Okay, they told us cosine is 2 over 3. And based on the triangle that we just filled out, we can figure out the sine part. Okay, so for the sine part, sine is opposite over hypotenuse, so that'll be rad 5 over 3. Okay, and we still have the 2 in front. So basically, all you got to do is calculate this out, and that'll be the answer to sine 2 theta. So as you can see, the double angles pretty similar to the sum and difference ones, except this time you're calculating it for 2 times the angle, not when you add or subtract 2 angles, but same idea, okay? Figure out what your formula is, okay? Figure out what you need to plug into there, and then go back to the problem and see if you can get the information either by what they give you or by drawing a triangle so that you can get the other parts, okay? All right, lastly, let's look at the half angle identities. So you've got your formulas over here. Let's just start by going directly into the problem and seeing what it looks like. So it says, find the exact value of sine of 165. So just like the last time you saw this type of problem, the first thing you should do is look at it and say, hey, is this one of my nice values on the unit circle? If it is, then go there, get the answer directly. Okay, so obviously 165 is not. 165 is between 180 and I think the closest one is 150. Okay, so you know that this is going to be between, let's see, sine of 180 is going to be 0, and let's see, sine of 150 is going to be like 1/2. So you know this has got to be some value between 0 and 1/2. You just want to figure out exactly what it is. Okay, so obviously then we're going to go to our formulas. This time we're going to use the half angle, which means your hint is if you multiply this by 2, that angle should be one of your nice angles on the unit circle, or else you won't be able to actually use this process. Okay, so if I take 165 and I multiply it by 2, I believe we get 330. 330 is in the 4th quadrant. It's definitely one of your nice values. So that means I can set this up as sine of 165 is equal to sine of 330 over 2. And now that I've set this up, we go to our formula. Okay, so if you look at our formula for the sine half angle, that's going to equal to plus or minus square root 1 minus cosine of A over 2. Don't do the plus or minus. I don't want you to think that there's 2 answers here. That's not what the plus or minus is for. We'll talk about that later. For now, let's just fill in the radical part. Okay, so that means this is going to equal to square root of 1 minus cosine of 330 all over 2. That's going to be the same as 1 minus cosine of 330, I believe, is going to be rad 3 over 2. Let me just write that a little bit nicer. Okay, and then all over 2. Make sure your radical goes all the way down, or else I think that it only covers the top part of the fraction. So anyhow, at this point, if you want to simplify, it's up to you, but I don't require you to, because if you leave it like this, at least I know where you're putting in the rad 3 over 2 and where you got it from. Okay. The one other thing left though is now we will go back to this plus or minus. So let me briefly explain what this plus or minus actually means here. Normally when you see plus or minus, that means you have 2 answers. In this case, that doesn't mean that. Okay. Obviously it doesn't make any sense if you say sine of a certain angle. You're not going to get 2 answers. You always get 1 answer, and this is no different. Okay. What the plus or minus actually means is what should the sign of your final answer be? Okay, so this is kind of how you look at it. So this is what you plugged in to the problem. Okay, but this wasn't actually what you were looking for. What you were looking for was actually this guy. Okay, so the reason why that's important is because this is what is going to dictate your sign. So what I mean by that is, where is 165 located? Well, 165 is located somewhere over here in the 2nd quadrant. In the 2nd quadrant, sign is always positive, so that means for our problem, your final sign is going to be positive. Now, if you didn't know any better, you might instead say, well, I plugged this in, so this is probably, where the plus or minus goes with. And if you use this one, this would make a big difference because 330, if you look at it, is somewhere over here in the fourth quadrant, and sine at this location is going to be negative. So basically, if you looked at the wrong angle and you used that to determine your sine, you probably would have gotten a negative here. Okay, so again, keep in mind the sign that goes here is the sign that goes with your actual location, not what you plugged in, to the formula. All right, so in this case, 165 is located in the second quadrant, therefore sine is positive, so our final answer is positive. Okay. All right, let's look at this one over here then. Find the exact value of cosine of pi over 8. Once again, first thing you want to do, look on your circle, see if pi over 8 is one of your nice values. Obviously it's not, so you're going to have to use a formula. In this case, since we're on the half angle identities, your hint is you probably want to multiply this by 2, because you're going to end up using the half angles. So if you multiply pi over 8 by 2, I believe you get pi over 4, which is good because pi over 4 is one of your nice values on the circle. So that means we can rewrite this as cosine of pi over 4 over 2. Okay. When we plug this into the formula over here, we will get square root 1 plus cosine of pi over 4 all over 2. That's going to be the same as square root 1 plus rad 2 over 2 all over 2. Okay, again, make sure that radical covers the top and the bottom of the fraction. And then lastly then, when we look at this, we are actually looking at this guy over here to determine the sign. Okay, so where's pi over 8? Pi over 8 is located somewhere here in the first quadrant where cosine is positive. So once again, our sign here is going to be positive. Now, if you looked at the wrong angle, you looked at pi over 4 instead, turns out in this case, you still would have guessed the first quadrant, so you would have been lucky and gotten it right. So in this case, even if you used the wrong one, you still would have, been all right. But obviously, I want you to use the correct one because you won't always luck out like that. Okay, so again, you always use the final location to help you figure out where the sign is. And then lastly, let's look at this guy over here, cosine of 600 over 2. So again, this goes back to common sense. The purpose of this problem is just to remind you that sometimes if you just simplify this, so 600 over 2 is the same as 300. Cosine of 300, you actually do know. Okay, cosine of 300, I believe, is going to be 1/2. Okay, it's one of those nice points on your circle. Okay, had you tried to use the formula instead, you would have done. Let's see, you would have done this guy over here. All right, so you would have gotten 1 plus cosine of 600 all over 2, and then you would have had a little more work to do here because cosine 600, you got to subtract that from 360 since this is coterminal, and then that'll give you what, like 240, and then you got to figure out what's going on at 240. So you still would have gotten the right answer, but again, in this case, if you had just simplified the 600 divided by 2 and looked at what you had, it would have been much faster. Okay, so again, just keep that in mind. Sometimes you don't have to use the formula. Sometimes common sense is, all it takes to get the answer. But most of the time, you will be using the formula. So obviously, you should be familiar with it. Okay. And then finally here, we've got some DIY problems for you to practice what you've learned. Okay, so for the first one over here, it says find the exact value of sine of 330 plus 120. Obviously, you're going to have to use the sum identity on this one. Over here, you've got cosine of 2 theta, so this is the double angle one. And then finally, over here, you've got cosine of 255. and it tells you to evaluate it using the half angle identity. Okay, so make sure you use one of those.